So, thank you all of you for being here today with us. We're gonna talk about some car hacking topic. And let's go fast because I think we made too many slides. Let's see. So, yeah, who are we? I'm Javier Vazquez. I'm a hardware security specialist. I work at CodeWhite, a German company. We pawn stuff. I'm from Cádiz, Spain. I guess you can figure it out already. I'm sort of dark stuff. And yeah, I reverse engineer stuff, blah, blah, blah. I like cake when it's not a lie, and barbecues. I mean, who doesn't like barbecues? So
hi everyone, I'm Ferdinand Noelscher, Ferdi for short. I also work at CodeWhite in southern Germany, and among many things, I also like barbecues, of course, and lasers. Like, lasers are fun, right? So we had to decide between doing stuff with lasers and car hacking. And I don't know. Yeah. Maybe you can imagine what we went for.
So, car hacking status. What's going on? So yeah, besides remote stuff, like yeah, focuses on the canvas because data, blah blah. Replay attacks, like yeah, you can record and then replay, like such awesome stuff. Like yeah, some researchers also found remote exploits like slashing with tires and stuff, but yeah.
Real hardware attack.
Yeah, it's like hardware stuff. So, and there are also some really awesome tools to help understand the UDS protocol. But is there anything else? So
yeah, chip tuning is like its own thing, but it has a lot of common with car hacking actually. It is car hacking. And there's ECUs being cloned, keys being dumped, and data being manipulated to get more horsepower or, yeah, that sort of stuff.
Yeah. Also, in the internal data manipulation, chip tuners often enable, for example, writing over OBD, which is disabled. That's actually quite a hack. I mean, you need to bypass checksums, RSA signatures. So that's a cool topic. And yeah, we all know OEM diagnostics, right? They can do also fancy stuff. So yeah, what's the secret? Yeah, my hat fell down. So UDS is not the only protocol, like really. There's also tunneling protocol, which is the canvas version of the keyword protocol 2000, which was used on all cars over K-line. And both offer a series of services, SIDs, which are like actually pretty interesting, but people don't care that much about them. And yeah, using these services, you can get a lot of fancy information, even mem dumps. So, want to explain that?
So yeah, let's compare the UDS and TP 2.0 very quick. So for TP 2.0, you actually have to negotiate a channel where the communication will happen between the tester and the module. So let me see. Yeah. First we have a response, like 200 is always the channel negotiation request, and like you can see the different fields split up, and on the bottom one you can see the response, which is 200 plus the target address, and then you can communicate.
Yeah, and then you have like the transmission. Transmission is just like the ID, which is the CAN ID. You have the frame counter, the frame type, and then like data, blah, 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 blah. We will share the slides, so don't worry if you're not getting it this fast. Then UDS, the only difference between UDS and TP is that you don't need to negotiate a channel. You just like broadcast, you have your type of frames, the first byte is the length and the type of frame. But in the end, the data that's in the payload is what matters. That's the SIDs, the firmware, whatever. So they are pretty similar. They are both transport protocols, actually. And just to make if it's somewhat visible, that's the difference between TP, KWP, and UDS. There's just like some services are like divided into more smaller services. Like on UDS, we have communication control. On KWP, you have, for example, startcom, stopcom, disable normal message. All that is handled by a single SID on UDS. You have 4 on KWP, which is tunneling protocol. So that's the only difference on a protocol level.
So here we will shortly list a couple of interesting services. So the first one is security access, which is the way you authenticate the tester against the ECU, right? So the security access will unlock different levels of functionality. It's like a challenge response. Then there's read memory by address. You give it an offset and it will return the contents. And often, but not always, requires security access. Read and write data by ID is like for example, for getting the VIN, the vehicle identification number. You give it parameters, retrieve the data. Request upload is like from the ECU's perspective. So don't confuse the name. It's like to retrieve the firmware from the ECU. And routine control allows to start like custom routines, for example, erasing the flash, triggering all sorts of stuff like.
There are some fancy routines we've found in some vehicles, well, ECUs actually, not vehicles. Name it Bosch, that would allow you to retrieve the boot keys in EDC17 and MED17. So basically you just trigger the routine, you get the key, and then you can unlock the bootload mode. So yeah, why all this stuff? Because CanBadger. So yeah, glitcher's gonna glitch. So let's take a look at the hardware overview. It's an Mbed LPC1768 or PC Espresso. It has external RAM, 128 kilobytes to speed things up, 2 DB9 for CAN, 2 debug headers, SD card, ECU power controlled by a MOSFET. We have UART, we'll see later why. 4 GPIOs if you want to add fancy LEDs. And it runs in 3 different modes: a standalone, USB, which is a CDC device, USB over serial, or network. And yeah, it can be powered with power and has a blinky LED. So that's really fancy. And it's really cheap to make. It's under 25 bucks.
Yeah, and we made it like easy to solder, so it's really easy to set up. So the firmware, consider it a proof of concept, okay? The actions are always handled by the CanBadger itself, so it doesn't really require a laptop or computer, whatever, to perform any logic. It's all implemented in the firmware, like UDS TP 2.0 parsing, raw CAN logging, just as a start. We have a man-in-the-middle mode, we have the emulator mode, and we also mentioned that you can have 3 different modes of operation. That is standalone mode without anything attached, UART mode, where you get a CDC device on your computer and connect with your terminal. And then there's Ethernet mode, which I will go into that, don't worry, but it's for use with the CanBadger server, so you can have multiple CanBadgers in parallel.
Yeah, so
fancy stuff.
Yeah. So just a quick overview on the protocol analysis. So yeah, many SIDs are already included in the firmware. It's just a switch case, so adding support for additional ones is really piece of cake. It's extremely verbose. It parses the SIDs and the parameters. Everything is done by the CanBadger firmware, so no need for PC, just the serial part, so you need a terminal, and everything is stored in the SD of the CanBadger, so you can retrieve it later. And works with UDS and TP 2.0. So yeah, for the interactive session is interactive, so it doesn't require scripting, and it allows you to perform actions on the go. I don't know if you guys saw before we were starting the presentation, I popped that termite and I was doing some stuff. That's actually the interactive session. So you start a diagnostic session and then you can think what your next move is going to be. You don't need like to write a script or anything. You can just try stuff, see what happens, change something, try again, like with no rush. And there are built-in scanners for SID parameters. So for example, if you want to go and check if there's any hidden type of diagnostic session, or you want to see what offsets are readable by read memory by address, or whatever you want to check, there are some built-in scanners for that to make things easy and fast.
So, let's talk a little bit about the man-in-the-middle mode. It's also, as I mentioned already, implemented in pure firmware. So on the right hand, you can see the original traffic on the top and the man-in-the-middle traffic on the bottom, where the payload has been changed. And on the left brackets, you can see that there's no delay added. So it's pretty fast, and we tested a lot with like 30 or 40 rules. And Basically, it will match any incoming packet on either port against your set of rules on the SD card, and it will like do basic operations like dropping frames, doing math operations, or substituting simple bytes. Yeah. So we thought we could make it even easier to use the CanBadger. So we wanted to have CanBadgers talking over Ethernet, so maybe they could exchange some data to each other, or just to have multiple ones running in parallel. And this is why we had the CanBadger server. It's written in Python, and here is a small snapshot. It's actually not themed, but it looks different now. So on the left hand, you can see the connected node, and this is where you will switch between different CanBadgers. And the GUI was really inspired a lot by Burp Suite, so you have everything in one place, and you can exchange data between different modules, like the logger, for example, send a frame from the logger to the replay tab, or create a rule for that. Yeah.
So security access hijack. Why? So yeah, we were talking about security access, and it's now starting to be more known. So yeah, just the tester authenticating itself against the ECU. So, but you need to know obviously the algorithm being used and the key being used. Since it's random, you cannot brute force it. I mean, the challenge is going to change every time, and after 3 failed authentication attempts, the ECU locks down for 10 minutes to 30 minutes. So no brute force in there. What's the other solution? Hijacking security access. So you just need a tool that is able to authenticate. You don't need to care about what the tool does. It just needs to be able to authenticate. So for that, for example, we bought a cheap clone interface for tuning the cars, and every time we want to have access to something, like, don't know, restricted diagnostics mode, for example, or reading some offsets that are not standard, we just hijack the security access. And yeah, then we have security access without caring about that. So how does it work? The CanBadger gets into a transparent mode, breach mode, so it waits for the security access to happen. If the security access succeeds, it will disconnect the external tool, and then it will take over the session and give you a nice menu with a lot of stuff to do. So yeah, let's try the demo. We're running a little bit bad on time, but why not? Let's try the demo. So let's fire up our Super Windows XP. Yeah, because why not? Yeah, we all love waiting, right? Yeah. Okay, so in the meantime, let's allow VMware do its thing. We're gonna do the demo in a while. Yeah. Let's let up because we're not that good on time. So yeah, let's travel to the future on the next slide. So yeah. So hopefully we survived the demo. So what else can the CanBadger do? So another fancy thing is dumping the TP and UDS transfers, which are used for firmware updates. So let's say a vehicle gets an over-the-air update, so that will be encrypted, signed, blah, 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 but then it needs to distribute the firmware updates over the network to the different modules. So it does that over the CAN, most of the time, not every time. So if it goes that way and it decides not to use encryption, which we have found some manufacturers do, then the CanBadger can just like grab the whole transfer and dump the data. So basically dump the firmware that was being updated. It can also spoof OBD2 data through the band in the middle and the emulator. The emulator is like some other fancy stuff we will explain later. And yeah, you can use GPIO pins for bootloading. For tricord, you know, like some people call it 0 day, it's just on the data sheet. We call it like a function. And yeah, it can manipulate GPS signals via UART pins.
So why did we mention GPS? Well, many of you guys might know those kind of donuts that give you rewards or allow you to track vehicles, for example, from insurance companies. And they turn your safe driving into savings. Let's play a game. So the thing with these dongles is that they implicitly trust the data that is coming from the car. It's requesting data over like diagnosis protocols, and also they're dependent on GPS, so they do have some cross-validation or some features that require that. And by spoofing the OBD data, you can have your own driving habits. Yeah, well, and maybe if you spoof your location too, it's going to be more money for you. So here we have an Android radio that's not a stock radio. So basically running an Android app connecting to a Bluetooth dongle that is plugged to the car. And you can see that there's like stuff going on, RPMs going up or down, but the car is not really turned on. And now you can see that we stop the CanBadger. The data will stop changing. Yeah, and there you see the feature. You can just control it with a button. You don't need to do anything.
So yeah, that was the emulator we were talking about. So how does the emulator work? So just set up a file inside the CanBadger ST and tell it to broadcast every 10 milliseconds whatever a request, which is a request for a PID, which is the data used by these insurance dongles. So it just keeps on making those requests as long as you want it to. You could be like 2 hours logging all the data that will be used for the emulation, which is actually real driving. I mean, you just like go around in circles for 1 hour logging the data, then you create the emulators. Once you create the emulator, you got the data, then you use the CanBadger to create the emulation data. So the CanBadger will look on which SIDs were used, which PIDs were used, and just like ask you from which one do you want to create the emulation data. So the way that the emulation data is stored in the CanBadger, because like we said earlier, everything is running inside the CanBadger, no computer needed for this, just press a button. So we created a header that has the IDs, the protocol used, the SID, the PID, and then the start offset and end offset. So that's sort of a lookup table. And then it maps everything else in the RAM. So whenever it gets a frame, I mean on every single frame it will check the contents of that frame against the whole emulation data. If it finds data that can be used for that SID, for that frame, then it will provide the emulation data. If it does not, it will just forward the request straightforward. So the dongle, the insurance dongle really doesn't know if there's anything in between. It's getting all the stuff. And yeah, it's a store using timestamps, so to get stuff real. It will only check for the data, or change the data when it actually changes, so to keep the emulation, yeah, well, what a genius. So the thing is that it will, to reduce the size of the emulation files, it will only log the changes using the timestamp. And yeah, when there's nothing left, then it just starts over. So yeah, now we'll do the demo. So yeah, let's do the demo now. Hopefully the Marble.
So we'll be having a workshop. Unfortunately, it's already sold out, sort of, but we're going to release all the code and schematics on GitHub, their GPL. You're also welcome to go hack the stuff. It doesn't have that much dependencies, and if you're like an embedded coder anyway, it will be really easy to get set up for you. So.
Yeah, or fancy Windows XP machine doesn't want to work, because why not? So let's show something else instead. We hope you guys will like it. So how much time do we have left? Okay, we have something. So are we connected to the CanBadger? Yeah, let's actually reset it. So that's the CanBadger USB interface. So right now we have an Bosch DC17 ECU connected. It's from a Volkswagen Passat. So let's have some fun with it, just to quickly show you how it works. So yeah, let's start a diag session. So you tell it your own ID, you tell it the ECU ID. So yeah, we got UDS session established. So then you say, okay, I want to read memory because I just want dumps. So yeah, let's try to read memory. So you tell it the offset. You tell it I want to read FF bytes. Whoops. We got an error. Service not supporting an update session. Okay, so let's see. Yeah, I don't really know what sessions are there, so let's scan for session types. There we go. So we have like different session types that can be initialized. 1 and 3 are standard, 40 and 4F are not. Yeah, I'll cheat a little bit because I already know it's 4F, okay? So let's try 4F. So let's switch to a custom one. Let's go for 4F. So it's established correctly. Okay, let's try to read again. So yeah, read, the same thing, yeah, sure, and FF. So damn it, now security access required. Okay, so yeah, again, we already reversed that ECU, we already have security access, so let's cheat again. Okay, so yeah, that was, well, it worked, awesome. So yeah, level 3, so yeah. So yeah, security access granted. Okay, let's see if it's true. Let's try again. So read memory by address. Let's try blah, blah, blah. And let's try FF. Yeah, so this time it worked. So, and we got a lot of fancy ASCII stuff. So that's sort of the way the CanBadger works. Like, you can interactively try stuff. You don't need to script. You can like, okay, let's see if this works. It doesn't. Okay, let's try something else. So it speeds up things a lot. And yeah, so let's like quickly, because we need to get out already. Blah, 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 blah. So yeah, I've talked a lot already.
So yeah, as I mentioned earlier, code and schematics, our GPL will be published on GitHub. Like, give us 1 or 2 weeks to clean it up a little bit, but we're gonna tweet about it as well. So you might want to get our Twitter handle. So yeah, we are very thankful for you having us here. Also, we'd like to thank CodeWhite, which have given us a lot of support and trust, time especially. And of course, our family and friends who've been supporting all the way down, even if we run out of coffee.
Yeah, thanks to everyone for being here today with us. And I hope everyone enjoys DEF CON.